Good day to everyone. My name is Joyce Inya Anajos, and for today, we will be discussing about the open-ended laboratory testing based on the question that we have got. Before I start, let me introduce my teammates. My name is Joyce Inya Anajos with TF210055, altogether with Jurin Alto Anak Jarup, Jonathan Tan Jit Leong, and Maisara binti Muhammad. Now, let's start with the question that we have got. So actually, the question that we have got is regarding the shear strength, load, and consolidation, which is the gutter foundation consultant needs to design a shallow foundation on clay soil. As it is known, the condition immediately after the completion of the foundation construction is always critical. This is due to full load applied on soil, but the soil has no time to gain additional shear strength through consolidation process. Therefore, we need to conduct a relevant experiment for shallow foundation construction, and the foundation must be designed according to the parameters that we got during the laboratory test. So, what is the answer for this problem? We have decided that the answer to this problem is direct shear test because based on the question that we have got, we identify the keyword as shear strength, load, and also consolidation process. But why, you ask? So here is the problem statement that we wanted to show. Well, since the questions relates to soil not having time to gain additional shear through consolidation process due to full load applied, we discovered that direct shear test is appropriate since it is a simple lab-based shear strength test which is performed in a shear box where soil sample, which is undisturbed, is positioned under different normal stresses, and shear stress will be determined in each case or consolidation stage. With that, we can work out the shear strength of the sample, and also we can find the cohesion and friction value of the soil. To further discuss, let's talk about the main objective here, which is we want to find the shear strength determination, and also we want to find the cohesion and friction value. All of this value will be important to evaluate the soil for stability assessment for shallow foundation.
A geotechnical laboratory experiment used to determine the shear strength parameter for soil or other granular material is the direct shear test. It is a fundamental test in soil mechanics and geotechnical engineering, providing valuable information for foundation, retaining wall, and other structure design. Engineer and geotechnician may determine significant variables like cohesion and angle of internal friction by sharing a soil sample until it's break. Where developing foundation, wall for retaining, and other geotechnical structure, these parameters are critical. In the following report, we will go over the core methodology, apparatus, and result of a direction test performed in our geotechnical laboratory. This experiment can be helpful for comprehending the way soil behave under shear stress.
The resulting data allow the determination of shear strength parameters, which is cohesion and angle of internal friction. The relationship between maximum shearing resistance and normal stress for soils can be described as in the equation of Coulomb's law, where C is a cohesion and theta is a friction. When friction components increase, the normal stress also increases, but the cohesion components are constant. If there is no presence of normal stress, then friction will disappear. This relationship can be pictured through the graph. There are several procedures that must be carried out for this experiment. Firstly, collect undisturbed soil samples from the outside. Then, weigh the samples and record the reading. steps to set up the shear box. Then, apply 1.75 kg of loads. Make sure the bubbles are at the center. Place the loading yoke on the loading pad and carefully lift the hanger. Lastly, record the horizontal and force-style gauge readings and repeat the procedures with different vertical compressive loads.
Hi, my name is Jonathan 10 with metric number of CF21052. I will present the result of this test for result specimen 1, which is 1.75 kg of undisturbed soil. We got the displacement for the die gauge is 260 with 2.6 mm. On proving ring, the die gauge constant at reading with the value of 36 with load of 0.0818 kN. The shear stress for specimen 1 is 22.71 kN per square meter, meanwhile the strength is 0.0433. For specimen number 2 and number 3, the load is same 0.01363 with both of them has constant reading on proving ring die gauge with the value of 60, which also means that them both have the same shear stress and strain value with 37.85 kN per square meter on shear stress and 0.1233 on strain value. This is the graph shear strength versus strain value for specimen 1. In this graph, we could see that the normal stress is 4.816 kN per square meter with shear stress of 22.71 kN per meter. Next, we could see the specimen number 2 and number 3 have different normal stress with the value of 6.88 kN per square meter for specimen number 2 and 8.644 kN per square meter for specimen number 3, but both of them have the same shear stress value of 37.86 kN per meter. In this part, it shows the graph shear stress versus normal stress from all three of the specimen, which we could determine the cohesion of the specimen, which is 7.57 km per square meter, and the friction of the soil is 74.75 degree.
For the question, in a comparatively short amount of time, the direct shear test is suitable for evaluating the soil shear parameter, friction angle, and cohesion value. We were required to plot the shear stress versus strain graph as the final step in the process. The graph will give the value of the friction angle. During testing, none of the three sample 1.75 kg, 25 kg and 3.25 kg produce any error. When the dial gauge reading increases the time by a specific amount of time, the value that is directly displayed by the dial gauge rises. The angle of friction and soil cohesion are calculated. The zero angle produced by the linear line is known as the angle of friction. If the sand was used as the sample label, it can be demonstrated that the friction angle is derived from the data.